Ladies and gentlemen, today you are going to want calculators. So if you don't have a calculator, please come grab your calculator that matches your desk number. They are numbered. It's hard to see because it's yellow, white on yellow, so it's totally weird. But grab a calculator. The proper number calculator. Should be the same as your computer, same as your desk. Desk, computer, calculator, all the same number.
Dude, that's so deep. Mine doesn't work. It's not working. It's just like slow.
So number one, I'll show that again. It should be fine.
Okay.
Yep. All right. Good morning, ladies and gentlemen. Now, you do not need your computers open right now, so go ahead and close those up. Because, thank you. Close those up. You don't need those. Again, just to clarify, when you have an assignment, hopefully you get it done during class. It's always my goal. If you don't, your job is to finish it up at home, okay? And if you do both assignments, please make sure that you show me that you completed both of the paper one is really the only one I can't verify digitally. So if you do both assignments, make sure I see the paper one so I can give you the extra credit that you could earn by doing both assignments. So today we're talking about rational numbers. I like to say rational fractional. Rational fractional. We've been talking about integers, and really what we're learning in this first unit is all the different types of numbers that we have, our big old number system, okay? So integers, we just learned, were the negative and the positive whole numbers, but those are just the nice, pretty numbers. And now we're talking about all the numbers in between and those nice, pretty numbers. So all the numbers in between are called rational numbers. Anything that can be written as a fraction. So that's why I like to say rational fractional. So that helps you remember that rational numbers are things that are fractions. Okay? Is 2 a fraction? It's a trick question. Is 2 a fraction? Yeah, it is, because I can make it a fraction, 2 over 1, right? And I could also say it's also the same as 4 over 2. That's also 2. All right? So I can take any number and I can make it a fraction just by putting a 1 under it. All right? So, but rational numbers would be something like this, potentially, where we have the numerator, and I know you know this already, and we have the denominator. And so any number that can be written with a numerator and denominator is called a rational fractional number. Rational fractional, okay? So I love saying that just because I think my entire job as a teacher is to help you remember stuff, okay? And I like rhyming. Rhyming and alliteration, super nice. Okay, so simplest form is a fraction that cannot be reduced further. It is reduced as much as possible. So when we have our fraction, we always want to make sure that can I divide by 2? Can I divide by 3? Is it as far as it can go? All right, we want small numbers. Really, it's just ultimately we're lazy, and small numbers are definitely better. So we want to write these fractions in simplest form. I am not going to do all of these because we've already done much of this. Number 1, 8 and 20. What can we reduce by? 4. Divide by 4, top and bottom, so we get 2 over 5, and that is fully simplified. What about number 5? Negative 12 over 42. What can both of those divide by? Not 12, but 6. So we can divide top and bottom by 6. And don't forget your negative. It's just going to hang out. 12 divided by 6 is 2. 42 divided by 6 is 7. And when I look at 2 over 7 with a negative, those numbers can't be reduced anymore. So that's as far as that goes. Okay. Something like 16 over 56, number 7 here, maybe, I don't know. So maybe we could check using our calculator, and I'm okay with this. So if I go into my calculator and I do 16 divided by 56, it gives me some crazy decimal, and all we need to do is math frac it. Math frac. So on your calculator, you have a math button right below the alpha key, and so you can math, and then number 1 is convert to a fraction, and just hit enter, and it'll reduce it for you. So to get to 2, we must have divided by 8, top and bottom. So 16 divided by 8 is 2, and 56 divided by 8 turns out to be 7. Hey, that was 2 7s as well. Crazy. Do I expect you to be able to do this without a calculator? I sure hope so. Okay. And again, you have calculators. You know, once upon a time, we always, our parents, my parents, used to say, you're not always going to have a calculator in your back pocket. And it's like, yes, I am. Like, you know, we all have a calculator in our back pocket now, right? So I have to be reasonable about that. And you do have calculators that you can use, but I hope that you can use your brain, okay? Because it is a muscle just like every other muscle, and if you don't use it, you're going to lose it, okay? And we're talking about early onset dementia, okay? It's a thing. Okay, improper form. What is improper form of a fraction? Finley, what do you got? That's exactly right. Improper form is when the numerator, I love how you use those words too, numerator is larger than the denominator. All right. Think about it as top heavy. All right. When it's heavier on top, that's an improper fraction. That is a number bigger than 1, okay? So we want to maybe think about that. Most of the time, improper form is okay in our class. I love improper form. It is okay. Mixed numbers. A mixed number is a whole number, and a proper fraction. A whole number and a proper fraction. So a proper fraction means that, well, it's not larger on top. Okay. So we're going to do a little bit of converting here. Write each improper fraction as a mixed number. So again, here we have an improper fraction because it's top heavy. It's got the bigger number on top. And so we say to ourselves, how many 6s fit into 19? Oh, yes, because 3 times 6 is 18. Very good. So 3 6s fit inside with how many left over? 1. And then we keep our denominator of 6. So 3 and 1/6. Hopefully you remember all of that. Yeah, do you remember how to do that? No? Let's try another. This one happens to be negative, but again, the negative, we're just going to take it along for the ride. How many 3s go into 26? Because 8 times 3 is 24, so it gets us close. Okay, so we got 8 3s, that gets us to 24. And then the difference between 26 and 24 is 2/3. So 8 and 2/3. If you don't remember how to do that, what's another way other than just using your head? How else could you convert to a mixed number? So, almost. With our calculator, if I can get, let's see, 26 divided by 3, I can see that I get the whole portion there of 8. So I can get part of it. Okay?
What happens if you math frac that?
So if I math frac that, that's a good question, I get back my improper. So that's what we use most of the time. So we like improper better. So it's actually just division, long division. So this is number 11. We can do long division. How many times is 3 going to 26? 8 gets us close. We multiply 8 times 3 is 24. We subtract and we get a remainder of 2. This is the remainder. A-I-N-D-E-R, remainder. And so that's what happens. We get our whole number, and then our remainder goes on the numerator, and the divisor of 3 goes in the denominator. Okay. So we can do it old school, but again, we're not going to do this a ton. Let's do one more. Let's do 13. How many 4s go into 21? What gets us close? 5. 4 times 5 is 20. What's the remainder? 1 over 4. 5 and 1/4. So 4 goes in 5 times with a remainder of 1 over our divisor of 4. All right, now this is a better thing to know how to do. This is converting to an improper fraction. Again, most of the time we want improper. Everything is easier in improper form. Do you remember how to convert from a mixed number to improper? Yeah, what do we need to do? Multiply the whole times the denominator there. So that would be 3 times 5 is 15. And then what do you need to do? Add the numerator there. So 3 times 5 is 15 plus 1 is 16. That is our numerator. And what's our denominator? 5. The denominator stays. Okay? What if we've got a negative? Does that change anything here? No, again, it's just hanging out. We're going to put the sign there, and we're going to worry about doing the same process as before, and you can avoid the negative. So we're going to multiply. 1 times 10 is 10, plus 9 is 19 tenths. Good? What about number 20? It's got a negative, so we're going to multiply. 7 times 4 is 28, plus 3 is 31 sevenths. Okay? Any questions on those? Okay, great. So again, most of the time we like improper fractions because that's how we do all of our operations. Let's turn the page, and this is where your calculator is going to come in real handy. Whoa, did I write that on yours? No. Oh, funny. All right. So converting between fractions, decimals, and percents is something that we want to be very fluid with in by 8th grade math here. So we're just reviewing this, and I am, we have calculators, so I'm not going to make you do everything longhand. So I am starting with a fraction. You'll notice that this fraction is not a mixed number. And so if I saw a mixed number, we would want to convert any mixed numbers. Okay, so when we do a few more, I'm sorry, you can't see that. Convert any mixed numbers. If you see a mixed number, you want to convert it to improper fraction, and that would be just fine. Okay. We are going to convert the fraction to a decimal. It is just long division. So if I wanted to, I could do long division and do 16 into 9, which is really weird. What do you have to do long division? What, like that? You got to add a decimal and a 0, right? So we put on a decimal, and it sort of makes it appear like it's 90 now, and then you can go from there, okay? But hey, we got calculators, so let's just skip the fluff and do 9 divided by 16, and you can see I wrote that in, and I don't know why I wrote it on this paper, but that's okay. So 9 divided by 16 in our calculators gives me the nice little decimal, 0.5625. All right? So in your calculators, you can do that. Now, if I want to convert a decimal into a percent, I don't know why I wrote division. That is wrong. A percent, we are going to just multiply it by 100. So I can take a decimal and multiply it by 100, and that now becomes 56.25. And it's very, very important that you put this percentage symbol on there. No, not for this. This is a decimal that stops, so it's perfect. It is an exact decimal, so we don't want to round that off because it's perfect. If we round it off, now it's wrong. Does that make sense? All right. Okay, so make sure that you put that percent on there so that we know that we're talking about a percentage. This is like 56%. That's like a little over half of something, okay? So keep that in mind. Now, maybe we're starting here at a lovely percent. And what this symbol, we read the word percent. That symbol, when you see that symbol, this word has a ton of meaning. It's not some random word. Per means divide. When we say miles per hour, we're dividing miles divided by hours. That's what we're doing. We're dividing. So the word per tells us what to do. So when we see 84%, we're going to divide. And what does cent remind you of? Century. Century. What about like dollars and cents? How many cents is that? Does that, what is it, how long is a century? 100, okay? And how many pennies, how many cents are in a dollar? 100, okay? So when we have the word percent, it's literally telling us what to do. It's saying, hey, take 84 and divide it by 100. And so you can see what happens when I do 84 divided by 100, we get 0.84. And what happened here was the decimal moved left 2 places. I don't like that. I hate that. I would rather understand that we just divide by 100. You can see I took the decimal was after the 4 and it moved 2 places. That's what happens when you divide. Makes it smaller by two spots. Okay. And now, here is the hardest thing. 0.84 has a proper name. 0.84 is the slang. What is this proper name? So you know how, like, if I gave you 23,407, okay, so I could be like 23,407, okay, but this has a long name. If I were to use its proper name to say this, what would you say, Easton? Oh, what were you gonna answer for that? 8,400. Yeah, it's like this is 23,407, right? So it has a really long name. This decimal has 84 hundredths. I threw myself off when I did that big long one. 84 hundredths, Hundred. Oh my God. Redths. Oh my God. I forgot how to spell for a minute there. 84 hundredths. 84 hundredths, the name of that decimal tells us its fraction form. 84 hundredths is 84 over 100. All right, 84 hundredths. Now, in our calculator, that's a pretty big number, so I'm going to go ahead and do 84 hundredths, and I'm going to math frac it, and we can see it reduces, yeah, to 21/25. So we can divide that, it turns out, divided it by 4 to get 21/25, and this is its fraction in a nice little proper form, okay? So this naming 84 hundredths is a nice way to write it as a fraction. All right, so we're going to practice this a couple of times here. Let's see. So I have 9/20. How do I convert that to a decimal? 9 divided by 20, sure. So in our calculators, will you use your calculator right now? 9 divided by 20. I want you to follow along. Make sure you know how to do it. And we get 0.45, okay? And then how am I going to turn that into a percent? Yeah, times by 100. And so I'm just going to multiply that by 100, and I get 45%. Multiplying by 100 has the effect of moving the decimal 2 spaces, but to make it a larger number, all right? We went from a small decimal to a large 45, okay? All right, I'm starting here at a 5%. What do I need to do to convert that to a decimal? Yeah, divide by 100. That's what percent means. So 5 divided by 100, and I get 0.05. 0.05. All right, now what is this proper name for 0.05? No, what you got? 5 hundredths. Yes, this is, we would call this 5 hundredths. All right, and 5 hundredths is what fraction? It's got a 5 on top, and what's its denominator? Hundreds. So 5 hundredths, and I'm going to go ahead and, let's see, I guess I'm going to math frac that. Oh, I didn't have to do it. It divides by 5. That's so silly. Okay, so I get 1/20. All right. Here I'm starting in the center. I have 0.26. What's its proper name? 26 hundredths. So that's going to be 26 hundredths, and I can reduce that. What can I reduce that by? Yeah, I can divide by 2. Very good. And so that would give me 13/50. Very good. And then how do we take that decimal of 0.26 and turn it into a percent? Move the decimal 2 places, yeah, or multiply by 100. Either would work. So that's just going to be 26%. Do you think you can handle this? Yeah, is that pretty easy? Let's see. I think there's a couple more that are a little bit weird. Let's do the next one, because 11 is a crazy number. So I need to convert it to a decimal. We're going to do what? $11 divided by 28, and we get, ooh, what's wrong with this decimal? Too many numbers. It goes on forever. This one is crazy. I don't think it goes on forever, but it is pretty darn crazy. So I think we're going to approximate this decimal, and it's an approximation, so I'm going to use a little approximation symbol here. This is not exact, but 0.3928 is probably, oh, should I do 8? Let me see. I'm going to do 2. Why am I changing the 8 to a 9? Yeah, well, yeah, but I'm looking at the 8, and then the neighbor to the right is a 5. That 5, I'm going to round up. All right, so I'm going to do that. Let's see. Now, if I have that crazy decimal, what's that crazy decimal's percent? 39.29%. Again, you can move the decimal 2 places, or if I just take this decimal, 0.3929, and multiply it by 100, there I get 39.29%. Okay? Let's get down to this one, the 1 1/9. That's a mixed number. What do I need to do to that? Make it an improper fraction. Yeah, so we're going to multiply and add. So that's going to be 9 plus 1 gives me 10/9. So there's my fraction. All right, 10 over 9. Ooh, what's that decimal? 1.111111111. Look at that crazy decimal. That is a repeating decimal. That 1 is repeating, so we can repeat with a little bar on top, just like that. And then if I take that, what do I need to do to convert it to a percentage? Multiply by 100. So I'm going to do that. I'm going to go ahead and times by 100. And now I get 111.1, and that decimal is repeating. Okay. All right. Do you have questions for me? Let's go one more, this last one. Right down to the bottom, the 55.5 repeating percent here. I want to convert that to a decimal. What should I do? Divide by 100, which effectively moves our decimal 2 places smaller, so we get 0.555555 repeating. I think I'm just going to make that 0.5 repeat. Can I do that? Because the 5 is just repeating over and over and over. All right. Little trick. When you have a repeating decimal, it's over 9. So I have the 5 is repeating. That's the numerator. It's always over 9. Look at that. Let's try it. 5 divided by 9, 0.555555. Interesting, huh? This is fun math tricks. There's a decimal 1, 2, 3, 1, 2, 3, 1, 2, 3, repeat. All right. It's repeating 123 over and over and over again. What do you think the decimal for that is? It's the repeated part, 123, over the same number of 9. Watch. 123 divided by 999. 1, 2, 3, 1, 2, 3, 1, 2, 3. Isn't that cool? So whatever the repeat is, you just put it over the same number of 9s. It's pretty fun. All right. Okay. Ladies and gentlemen, do you have any questions for me? All right. Oh, let's see. Hold on. All right. Today you've got 2 choices again.